Today's lesson is going to be talking about rational exponents and radicals. And so by the end of the lesson, you should be able to say that I can rewrite expressions involving rational exponents and radicals. So before we can start today's lesson, we first need to think about what we already know. So if we look at these radicals here, we have this first one is the square root of 4x squared. If there is no number here, we always are going to know it's going to be just the square root. And we can actually solve this. The square root of 4x squared is just 2x. Looking at the next one, we have the cubed root of 8y cubed. And if we solve this, we get 2y. And last but not least, we have the fourth root of 81n to the 4. And when you solve this, you get 3n. So we may know how to read radicals, we may know how to solve radicals, but what we need to think about is we need to think about the parts of a radical expression. So if we have a radical, a, and it's the nth radical of a, we have different parts here. The n, here, this is our index. So it's important to know which part of the radical is your index for when we get later on in the lesson. The a is our radicand. Radicand. Radical, radicand, very similar sounding. And then the symbol itself is the radical. Radical. And so what we're really going to be focusing on and what we're going to hear a lot today are the words index and radicand. So to get started, we have a definition. The equivalence of radicals and rational exponents. What it says is as if the nth root of a is a real number and m and n are positive integers, then here's what happens. If we have the nth root of a, this is the same as a to the 1 over n. Notice your index is the denominator in your exponent. Also, if we have the nth root of a to the m, we could also write this as the nth root of a, all raised to the m power, and this is the same as a to the m over n. Notice the index is always the denominator. The exponent, no matter where it's sitting, but your exponent is always your numerator. So the index is the denominator, and our exponent is the numerator in the new exponent. Because notice on this a up top, technically there is an exponent of 1. That's why the numerator in that exponent is a 1. And so going from radicals, have the radical symbol, so those three are our radicals, to rational expressions, where it has an exponent, and because it's a rational, it's most likely going to be a fraction. So here we have a rational exponent, and we need to write it as a radical. The radical, we can put in our radical symbol. 81 goes inside. Our power is 1. Our index is 4. So really, it's the fourth root of 81. The fourth root of 81 is 3. Next example, m to the 3/5. We can put in the radical. In our radical, we're going to have a m. The power is cubed. The index is the 5th. We could also write this as the 5th root of m, and then have that cubed. These are equivalent expressions. So, we have a little practice on radical versus exponential forms. So remember, radical form uses a radical. Exponential form uses an exponent. Remember, it's probably going to be a fraction. So if we throw some examples out there, what if we have the square root of a to the 3rd? Well, if we change it into exponential form, it's going to be, our base will be a, because that's our base in here. Our exponent is the exponent over the index. Nothing's written, so we know it's a 2. So it's going to be a to the 3/2. Now what if we went the other way? What if I gave you m to the 5/2? What would that look like as a radical? Well, we know it's going to be a radical. We know m's going to be inside. The exponent on m is going to be a 5. The index is going to be a 2. So, because it's 2, we're not going to write it. We could also write this as the square root of m to the power 5. Equivalent things. And now, one more. What if I gave you the cubed root of m to the 7th? Well, it's going to be an m for our base, and our exponent is the exponent over the radical index. So we're going to have 7/3.